Hello everyone. In this matrix, we are going to find the eigenvalues and eigenvectors. Let us keep this matrix as A. We know the characteristic equation of A. We can write that. In the previous problem also, we have seen these. Here, S1 is the sum of the diagonals. 2 plus 1 minus 3, it will be 0. S2 is the sum of the minus along the diagonals. This 2 is the first diagonal member. We need to cut the row and the column along that. Then we need to take this. This one is the second diagonal member. We need to cut the row and the column along that. Then we need to take the rest. Minus 3 is the last one. We need to cut the row and column along that. Then we have to take these. 1 into minus 3, it will be minus 3 minus 1 into 2, it will be 2. So we will get minus 5. 2 into minus 3, it will be minus 6 minus 7 into 0, it will be 0. 1 into 2, it will be 2 minus 2 into 2, it will be 4. 2 minus 4, it will be minus 2. In this way, for S2, we will get minus 13. We have calculated S1 and S2. Now we are going to find S3, that is a determinant of A. 2 into, then we have to cut the row and column. We have to take this minus 2 into, then we have to cut the row and column. We have to take these plus 0 into, then we have to cut the row and column. We have to take these. For S3, we will get a minus 12. In this one, let us apply the values of S1, S2 and S3 so that we will get this. We need to solve this equation. First for lambda, we have to apply minus 1. We will not get a 0. Then we need to apply 1. We will get a 0. Here we have 1. Here 0. Here minus 13. And then 12. We know that when we apply 1, we will get a 0. So we have to enter 1 here. Initially, we have to apply 0. 1 plus 0, it will be 1. 1 into 1, it will be 1. 0 plus 1, it will be 1. 1 into 1, it will be 1. Minus 13 plus 1, it will be minus 12. 1 into minus 12, it will be minus 12. 12 minus 12, we will get a 0. So this equation will be equal to lambda minus 1 into lambda square plus lambda minus 12. When we add minus 3 and 4, we will get to 1. And when we multiply both of them, we will get to minus 12. So instead of this, we can write lambda minus 3 and lambda plus 4. In this way, we are getting the eigenvalues as 1, 3 and minus 4. Now we are going to find the eigenvectors. We need to use this equation. We have to subtract lambda by the diagonal members so that we will get these three. We have seen this very clearly in the previous problem how it comes. For x, we have to use this matrix. Since the size of the matrix is 3 cross 3, inside X matrix we will have x1, x2 and x3. There will be 3 members. First for lambda, we need to apply 1. 2 minus 1, it will be 1. 1 minus 1, it will be 0. Minus 3 minus 1, it will be minus 4. We need to multiply this row with the column, we will get this. Then with this row and column, we will get this. And finally this row with this column so that we will get this. Let us take the first two equations and then solve. X1 upon, we need to cut the coordinates with the x1. 2 into 1, it will be 2 minus 0 into 0, it will be 0 minus x2 upon, we need to cut these. 1 into 1, it will be 1 minus 2 into 0, it will be 0 is equal to x3 upon, we need to cut this. 1 into 0, it will be 0 minus 2 into 2, it will be 4. If we want to, we can change the signs in all three members. It will become negative and here it will be positive and here it will be positive. So the corresponding eigenvectors are minus 2, 1 and 4. Now instead of lambda we have to apply 3 so that we will get these. Then we have to multiply the rows with the column so that we will get these 3. We can take these two equations and then solve it. X1 upon, we need to cut this. 2 into 1 it will be 2, minus 2 into 0 it will be 0, is equal to minus x2 upon, we need to cut this. Minus 1 into 1 it will be minus 1, minus 2 into 0 it will be minus 0, is equal to x3 upon, we need to cut this. Minus 1 into minus 2 it will be positive 2, minus 2 into 2 it will be 4. In this way we will get the eigenvectors as 2, 1, minus 2. Now for lambda we have to apply minus 4 so that we will get these. Then we have to multiply the rows with the column so that we will get these 3. We can take these two equations and then solve them. X1 upon, we need to cut these. 2 into 1 it will be 2, minus 5 into 0 it will be 0, is equal to minus x2 upon, we need to cut these. 6 into 1 it will be 6, minus 2 into 0 it will be 0, is equal to x3 upon, we need to cut this. 5 into 6 it will be 30, minus 2 into 2 it will be 4. 2 into 1 is 2, 2 into 3 is 6, and 13 2 is 26. In this way we are getting the eigenvectors. Now we can write the answers. We have found the eigenvalues and the eigenvectors. Let us see one more problem. In this matrix we need to find eigenvalues and eigenvectors. Let us keep this matrix as A. We know the characteristic equation. S1 is the sum of the diagonals. When we add these three, we will get 18. S2 is the sum of minus along the diagonals. For that, we will get 45. S3 is the determinant of A. For S3, we will get 0. In this one, let us apply the values of S1, S2 and S3 so that we will get these. In this one, we can try with minus 1, 1, minus 2, 2, minus 3 and then 3. For 3 only, we will get 0. So we have to enter 3 here. So this one, we can write like this. We can take this one, lambda square minus 15 lambda is equal to 0. We can take 1 lambda outside. So it will be lambda minus 15 is equal to 0. From here we will get two values. Lambda is equal to 0 and lambda is equal to 15. So the eigenvalues are 3, 15 and 0. Using this one we can find eigenvalues. First for lambda we have to apply 3. We can take these two equations and then solve them. In this way we will get corresponding eigenvectors. Then for lambda we have to apply 15. We can take these two equations and then solve so that we will get the eigenvectors. Finally for lambda we have to apply 0. Using these two we can solve. For the eigenvectors we will get these. Here we can write the answers, the eigenvalues and the eigenvectors. Now we are going to end this session. Thank you for watching this video.